For homework 16, I want you to watch a brief 6-minute video on ENSO, El Nino Southern Oscillation. But before you watch it, I want to give you a few bits of information that will help you, because we haven't talked about some of the things in oceanography yet that are mentioned in the video. First of all, we haven't talked about ocean circulation yet, so I want to give you a really quick overview of some concepts that the person in the video goes through really quickly. On the left is a diagram of the idealized global winds, and that you should be familiar with. Remember, we have the trade winds blowing between 30 north and the equator and 30 south and the equator. These are blowing from the subtropical high pressure zones to the equatorial low pressure zone. And they are going from northeast to southwest in the northern hemisphere and southeast to northwest in the southern hemisphere. So these are the northeasterly trade winds in the north and the southeasterly trade winds in the south. Then at higher latitudes we have the westerlies blowing from the west in both hemispheres. So the red arrows on this diagram are showing the surface flow, and then the blue arrows are showing the return flow at higher elevations. These wind directions are shown in this diagram. The trade winds are shown with the light purple or gray color here. And then the westerlies are shown with these green arrows. What's shown with the purple is the resulting movement of the ocean. The surface waters of the ocean are moving in what's called a gyre, a big circular motion because of the winds. So global winds drive the ocean circulation at the surface. Notice in the northern hemisphere these gyres move clockwise, and in the southern hemisphere they move counterclockwise. If I try to show this on this diagram over here, first we have the ocean moving from east to west near the equator because of the trade winds, and then there's a return flow pattern from west to east at higher latitudes, again because of the westerlies. So that's one thing I want you to be aware of, is that ocean circulation at the surface is driven by the global winds. Here's a map showing all of the ocean circulation gyres. We have 5 major gyres: the North Atlantic gyre and the South Atlantic gyre, which I just showed you, the Indian Ocean gyre, which we just have one of because we don't really have any ocean in the northern part of the hemisphere here. Then we have the North Pacific and South Pacific gyres over here. The video focuses on the Pacific Ocean because that's where the effects of La Nina and El Nino are most pronounced. Each of these is further divided into individual currents: the Kuroshio current, the North Pacific current, the California current, the North Equatorial current, and they're also indicated here in color as to whether or not the temperature of the overall water is warm or cold. Notice that along the equator, there's warm water currents occurring from east to west in both hemispheres. There's also something that's between them going in the other direction called the equatorial countercurrent. And this countercurrent, which is returning some of the water that's going from east to west, is generally a rather weak current and not very important in the overall ocean circulation. But I do want you to be aware of the fact that it's there, because it does become important during El Nino years. Each of these gyres thus has an equatorial current related to it, and then it has what we call a western boundary current. That's on the western side of the ocean basin. And so in the north, it's the Kuroshio current, and in the south, it's the East Australian current, made very famous in the Finding Nemo movies. So she mentions the western boundary currents, and this is what she's talking about: these currents that move away from the equator that are located on the west side of the ocean basins. So I just wanted to make you aware of these surface currents that we really haven't talked about yet. Now, the ocean also circulates vertically. It circulates from shallow to deep. And when ocean water comes from the deep to the surface, we call it upwelling. When it comes from the surface and goes down, we call it downwelling. And we're not going to talk in detail right now about how exactly this happens, but generally it has to do with density and the fact that cold water is more dense than warm water. One reason why upwelling might occur is if there are winds that are preferentially blowing surface waters away from shore, that deep water will come up to replace the water that's being blown away by these purple arrows. That water is cold and it's nutrient rich. Now, why is that? Well, if you think about it, all the fish that swim around out here are eventually going to die, and if they're not eaten, their bodies fall to the bottom of the ocean. So that's just like a big salad bar down there for fish. So when upwelling occurs, all of that nutrient goes up over to here. And so large regions of fish occur along the coast where upwelling is common. These are areas such as off the coast of Peru, where they're very famous for their anchovies, where there's a lot of fish. If upwelling stops for some reason, then these fish can die, and actually economies that depend on that can be in trouble. So upwelling is going to be mentioned in the video, and I wanted you to be aware of what exactly that means. Downwelling is not mentioned in the video, so we don't have to worry so much about that. But downwelling is important as well, because what downwelling does is it brings oxygen, which is more concentrated in surface waters, down to the deep. And oxygen then can be used by animals that swim down here that need oxygen without having to go to the surface. Finally, I just want to clarify two diagrams that you're going to see in the video. This one is shown in a discussion of temperatures that occur in the seawater during El Nino and La Nina years. But I want to clarify that these two diagrams are not actually showing absolute temperature. They're showing sea surface temperature anomalies. And an anomaly is a temperature difference from normal. So on a year that would be considered normal, these globes would show temperatures around this zero value of light blue to green. When you see large red areas, it means it's warmer than average, and usually that's a 30-year average. So in this particular example, and this is the equator, you can see North America up here, this region is about 4 degrees warmer. The seawater is 4 degrees warmer at the surface than average. And you can see that off the coast of North America, there's California, it's also quite a bit warmer than normal. There's also some cold pockets as well, colder than normal. During a La Nina year, the equator has much colder water than normal, as does the coast of North America and some other pockets. So I wanted to make it clear that these are temperature anomalies, not just temperatures, because if they were just temperatures, you might think, well, maybe the equator is always warmer than the surrounding water. So I wanted to make that clear. One other diagram that she goes through really quickly is this one. And what this is showing is the history from about 1950 to 2015 of La Nina and El Nino phases. And this is a good example of why it's called an oscillation, because really we think about these two events as oscillating back and forth. We're never really steady in between them. We're either heading towards an El Nino or heading towards a La Nina. Down below, these are the El Nino events, and above, these are the La Nina events. The higher they are away from this 0 point, the more intense they were. And during the video, the narrator is going to talk about this 1983 El Nino event, which was very extreme, and you can see it right here. So this is showing the periodicity, or sort of the lack of periodicity, of these events. They seem to happen every 2 to 10 years, something like that, but there's not a real definite pattern. Okay, so those were the few things I wanted to clear up. Now go ahead and watch this video. It's 5 minutes and 45 seconds, and then try your homework. Good luck.